And now let's discuss another suggested reading, which is coming from the Epstein and Axel's Growing Artificial Society. And there we have one particular interesting animal. There is what was its name? Yeah, it was sugar animal eating sugar on this sugar scape, right? Right. And this is a sugar scape where here and there has much of the production of the sugar, right? In Korean, sweeties, right? And sweets and like candies. And this sugar scape animal is being gathered around here to get those sugar productions. On the outset, there are some sparse sugar productions, so there are not that many, but there are a few sugar animals there. Why? Because these sugar animals do not have to be bothered by the competitions. Like here, it looks like Seoul, New York, Tokyo, any of those places where we have to pay high price because of the competition for the land, competition for the groceries, and so forth. If you just go outside a little further, right, then actual growth there will be limited. However, you will have a less competition, and there will be what? Equilibrium in terms of the residence. And here, Epstein and Axel both are fine complexity theorists, and at the same time, I would say that they are also social scientists. And many of these crucial, important social processes are are complex, okay? And these processes, like determine decision-making processes, where do I live, right? How to supply those key resources to those residents. Those are the social processes which are quite complex. And these economic, cultural, and demographic sub-processes are intermingled to each other, okay? So here, each of these sugar animals are not deciding where do I live by itself. It settles down by observing the environment and the other's behavior. Observing the other's behavior, meaning observing the competition on the resources, and that's the reason why they move around. And this is one very simple type of the agent-based model, and that is imitating this not neatly, not clearly decomposable process of each individual's decision making. And it's very difficult to test the hypothesis because these are all intermingled together. So and they are all intermingled so that there are relationships between individuals, and these are complex. Because why? Because n number of individuals, these relations are not that simple. It's not just itself. It's not just a one's characteristic features. Rather, we have to consider the n by n interactions. And so that because this is quite microscopic, because we are looking into the individual's behavior and individual's motive, macroscopic regularities cannot be easily tested. So that, for example, let's imagine that we have a macroeconomic model governed by a one regression, linear regression, or complex Armagh-Arch models and so forth, which are just a complex version of the linear regression. And these macroscopic approaches will not provide enough hypothesis testing in terms of this relationship between individuals. Okay, so up to this point, what people did in terms of the social science or even economics is that standard practice is suppress all real-world agent heterogeneity in model building. Okay, even these suga animals are different. They are not homogeneous. Why is that? Because their locations. Their location selection makes them heterogeneous to the response to the others. Because they are all having different competition level and different production levels nearby land. So to impress our standard practices that they are all being suppressed to a model population. And then after that, after the suppression of all those heterogeneity, and then simple statistical models or complex statistical models have been developed. However, is that really true? Is it capturing the real world? We simulationists hardly see that. So one step ahead, one step further than those standard practices of the statistical model would be analysis on the game theory or further step into the construction process of the general equilibrium theory. Okay? So you know that John Nash created his Nash equilibrium model by asking the Adam Smith's invisible hand how to come up with some mathematical answer creation process of those equilibrium. And in that process, game theory has been built. And this game theory changed previous concept of the preoccupied static equilibrium model, because that game theory is actually a search for the equilibrium point through the interactions of the individuals and actually impact their dynamic. And those were being started, emerged, and being modeled. And how to overcome these difficulties. So these were being limited representation of real world, particularly one in terms of the interactions. So we need more heterogeneous modeling and interaction modeling to make these as complex model. And so that what we are going to do and what Epstein and Axter is suggesting is creating an artificial society, like a matrix model, like the movie. Let's create a virtual world, artificial society, and let's put our problems in this artificial society and observe, even though these models are very simplistic models. Let's observe this society and see how it progresses and to come up with our own solutions on our own real world problems.